welcome to Ripple's Tutorials, and today we'll be looking into a topic called straight line graphs. Now there are two main methods, but we'll be using the first method, and as you go into year 10 and year 11 we'll be looking into the second method. The first method is quick and fast. You will not be doing much of subtraction here and there to get your gradient, and so let's go into it. Now method 1, we'll be using method 1, so let's just call that method 1. Method 1. Okay, good. Now, to begin, we need to have in mind, or we need to remember the equation for the straight line graph. We have y is equal to mx plus c. Beautiful. Now, this will be broken down into two parts. We have the c. We're going to cut out the c and don't put the addition sign with it, so we're going to leave the addition separate. And then we have the mx, okay, and then the addition sign is just from there. Don't include it with a c, it stands on its own, so it's a standalone. And then we've got a c. Good. Now let's call the c number 1, and then we'll call the mx number 2. Now let's begin with number 1, which is our c, number 1 here, which is our c. Okay, let's create a box around it. That's what we want to talk about. Now, what is c? What does it stand for? Now, the c stands for the y-intercept. I will explain that in a minute. We have y-intercept. Okay, intercept. The y-intercept. What is y-intercept? Oh, good. We have y-axis, okay, and then we have x-axis. The x-axis is the shorter one, so we have that. It's a very short one. The y-axis is not as tall, it's very, very short. You can see that. So from here to here is very, very short. And then the y-axis is here, and which is very, very tall. So it is the y-axis, very, very tall. Beautiful. Good. So we have differentiated both. We have nothing to do with the x-axis now, and we're looking at the y-axis. So the y-axis is there. Good. Now, y-intercept. We go to our y-axis, and then we go to our question. On the left-hand side, we've got a question. We can see the line running from the bottom to the top. And now we're going to try to copy that. We draw our line. I will use a red line here. And I'm going to run from the bottom to the top. And it goes this way. We can see that as the line was being drawn, it passes through the y-axis. So this is the bottom, started from here, and it went up. And as was approaching, it passes through the x-axis. We have the x-axis there. It doesn't stop. It kept it going. And then when it got to the y-axis, it cut through the y-axis and proceeded. Now the point at which it cuts the y-axis is what we're talking about. So it cuts it here. So the point at which it cuts the y-axis is referred to as the y-intercept. So intercept is where two things meet, intercepted at a particular point. So the point at which the question, which is your straight line, cuts the y-axis is referred to as a y-intercept, which is also your c. So that is what c is. C is where your question, which is a straight line, cuts the y-axis. Find that particular point. There's a number there. Write down that number. That is the value for your c. Beautiful. Sorted. Now let's go to the second part, which is mx. So we go to 2 here. And we have mx. Mx there. Good. Now mx stands for the gradient. So we have gradient. Gradient. Now you must note this, that your gradient can either be positive or negative. Now here, looking at our question, we will see that the line runs from the bottom and it goes to the top. It's ascending. Oh, beautiful. So we have ascending or descending. We have ascending, ascending, or descending. Descending. So when you observe that the line seems to be going up, which is ascending. That means your gradient is positive. So we have a positive gradient there. And when the line runs from top to bottom, then we know we have a negative gradient. So whatever we get as our mx depends whether the line runs up or down. Sorry, there's a mistake. That's supposed to be a negative, not a positive. So negative, yeah, negative there. So let me just put it in a circle. So negative there, and positive there. So when it runs from the bottom to the top, that means it's taking off, it's flying, is increasing in height. That is ascending, and that is positive. But if it's coming from top to bottom, it's descending, like an aeroplane descending, going down to the runway, and for the passengers to come down. So we have descending, and that is negative. So the aspect of ascending and descending is sorted. This determines whether your gradient will be a negative or a positive. Now, the gradient, how do you get a gradient? Now, the formula for the gradient, which is quite simple to understand, is what? Is rise over run. We have mx there. Mx is rise over run. Okay, now the rise is rising, like the sun rising, starts from a point and it goes up. But there are times that when we look into the graph, we don't see rising, instead we see it coming down. So rising is always found on the y-axis. So it's either from the bottom it goes up, and there's times that from the top it comes down. It's all the same thing. So rise is always found on the y-axis, while run is found on the x-axis. So let's make it this way. So here we have a point here, and rise is there on the y-axis. So it's either from here, let's call this point 1, and then here is point 2. So it can move from here, rise from there, it goes up. And at times that is actually from there and it goes down. It's still the same thing. So that's referred to as rise. Now let's go for the run. Run is on the x-axis. Let's put 1 here. So this is y-axis section. Good. And then this other one is going to be for your x-axis. So on x-axis, it runs from here to there. So let's put the x there. So run is on the x-axis, and it runs from one point to the other. So let's have it this way. It can run from this point here, which is point 1. Let's put the point 1 there, and it runs to point 2. Okay, and it runs from here and runs there. Or it can run the other way. From here, it runs back there. So it's still the same thing. So run can either be from one point to the right, or from right to the left. And for rise, it can be from bottom to top, or from top to bottom. So rise over run. So that gives us our mx, and our mx is gradient. Now we're going to be looking at the question on the left, and we're going to be putting all this to use to get our answer. Now let's quickly go here. Now we have a question. Now the first thing is the equation. What is the equation? The equation is y is equal to mx plus c. And I'm going to quickly divide it into 2 parts. We have the c there, and we have the mx there. We can observe that our addition sign is not included in the box. Beautiful. Now let's go. Now we go for the c first. Okay, c first. Number 1, c. What is our c? C is where it cuts the y-intercept. So where's the question? This is the question, and it runs from there, from bottom, and it goes up, 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 and it cuts it there, and it keeps on going. So that is where our answer is located. Our answer is located where? It's located here. And that is what is in between 4 and 5, and this is 4 here, and then it goes to 5, and then goes to 6 in between. Sorry, that's 4 and 6. Good. So it's between 4 and 6. In between 4 and 6 there, it's a 5. Okay, so let's rub that off. I want to make it neat and tidy. So our C is what? Is 5. A positive 5. So let's just leave it as a 5. Beautiful. So if you really want to rewrite this, we can now say we've got in part of our answer. We have y is equal to mx. Mx is still due. We don't have it yet. And that's going to be plus 5. So what we have lacking right now is our what? Is our mx. So let's deal with the mx. Good. Now our mx is the gradient. Let's write it out. So that's going to be the second part. We are looking for mx. What is our mx? Mx is the same thing as the gradient. which is the slope, gradient, gradient, okay, gradient, gradient, good. So that's gradient. Now, let's look at our gradient. Now, we will observe that we've got our x-axis here, and we've got our y-axis there. Good. Now, we want to create a triangle, a right angle triangle. It's important that you have this in mind. Once you have your right angle triangle, then it becomes easy. Then you can easily see the right and the wrong. So what we want is we want something like this. We want a right angle triangle like that, like that, like that. There's a right angle triangle. And then we have, this is the bottom where we have the 90 degrees. And we want to get from here to this point to this point. That's our right. And then we're going to go 1 and 2 and 3 and 4 and 5. Beautiful. And then here we're going to go this and this and this and this and this. And that's going to be our run. So our run is there on the x-axis. And our rise is there on the y-axis. So that's what we want. We want to create a right angle triangle. Good. Now let's drop this off. This one goes off, off, and off. And then we now go to our question. Now, looking into this particular question, we have a little bit of issue here. Now, the best thing to do when you have this kind of a question is look at your x-axis, look at your y-axis, and look at the line. And then go for this. Go to the point where it cuts the y-axis, which is your y-intercept. We have that already. And then go to where it cuts the x-axis, and we have the x-axis there. And then you now create the triangle. You now create it like this, from here to there, from there to there, and then you have the slope there. Beautiful. Good. Now, we want to do the same thing here, but we have a problem. Now, the problem is, now, it cuts the x-axis at this point. And that is, it's not 3. In between 4, minus 4 and minus 3 is minus 3. And that seems to be in between minus 3 and minus 3. That is 2.5. Now, we don't want decimals. We want a whole number. So we're going to try to avoid that. And we need to find another point. And another thing to observe is where we've got this. Let's quickly have this. We got 2 here. And then we've got 3 here. Beautiful. And there is no line here. There is no line here. No, there's no line here. But there is a line here. There is a line here. There's a line here. And there's a line here. So we can observe that at this point here, there is no line here at all. So we can't find a line running from top to bottom similar to the y-axis. We don't have one. We don't have one there. And because we don't have one there, we're going to ignore that point and try and find somewhere else. So here, we're going to ignore 2 minus 2.5. We're going to find another point. So now, let this one disappear. And we can't take that point. Now, if we go a bit further down, we can find another point here. This point seems to be good. Now, what makes it good is we have a line running from left to right here, which is similar to your x-axis. It's just a bit below your x-axis. Fantastic. We have another line running from top to bottom. Here, which is good. And then finally, we have our question running from bottom to top. And we can see that these 3 lines are passing through the same point. So they're passing through this point here. This point. Beautiful. That means we can make use of this point. So that point, that position is good. We have another one here. This point is also good. So we can see this running from left to right, which is good. And then we have this running from top to bottom, which is excellent. And we also have our question also running in between it. Good. And then we have another point. This point is also good. This point is also good. But this point here is not good. This one here is not good. And the reason why it's not good is we only have 2 lines. We have this, which is good. We have our question, which is good. From here, it runs through it. And then finally, we don't have the third one. The third one is missing. The third one seems, if we are to create a third one, it's going to come from here. It's going to run down. and that's not going to be right. So we don't want that one. So that means that point is not good. Now let's tidy up. Tidy up. And tidy up. And let's rub off this point here. Good. So we've decided that we will take a point where the tree line meets and where it's that. And that is, yeah, let's take this point here. Yeah. Or we can take this one here. Good. And then the first one is sorted, which is here. Good. Now let's create our triangle. Now create a triangle. We can start from this point here. We go down, down here, and then there. Okay, good. Good. And then we now go for our slope. Our slope is here, from there to there. Good. So if we to draw it, we have 1 here, and then there, and then there. Beautiful. Good. Now let's get our gradient. We'll rub this off. We did our rise. Okay, rise is on the y-axis, so we have mx is equal to rise over run. Rise from this point here. We rise. Let's go. We go 1, 2, 3, 4, 5, 6, 7, 8. You have 8. And we have run. Run is 1, 2, 3, 4. 4. And that gives us what? 8 over 4 is 2 over 1. And 2 over 1 is something that's 2. So our gradient is 2. So our mx here is equal to 2. Now let's rewrite the whole thing. Our equation is y is equal to mx plus c. So our y is, a gradient is 2. So we put a 2 there. We don't forget the x, we add the x to it. And we've actually obtained our c. Our c is 5, which is a plus 5, and we put the 5 there. And beautiful, we're done. So here, our answer is y is equal to mx plus c. In this particular question, the line runs from bottom to top. It's ascending, so it's positive. But we're going to be looking at another question where our line will be running from top to bottom, which is negative, where we're going to be having a negative gradient. And then we're going to deal with how to, where to put the negative sign, and that will give us our answer. Beautiful.